Hello all, welcome to our channel Way to Know. In this video, we will talk about the usage of accelerometer on Arduino Nano 33 BLE board. So you have a board here, okay, where you can see this is actually a DHT11 sensor. The board has inbuilt accelerometer, gyroscope and magnetometer IC, which is BMI270. Okay, so now this particular sensor can measure accelerometer and then the angular velocity using the gyroscope, and then the magnetic field strength using the magnetometer. Now if we see here, okay, so on this I'm not sure whether you are able to read the values or not. Okay, so we will explain first how the accelerometer is going to work. So when you have this particular sensor, okay, moving in x direction, okay, and then in y direction, okay, and in z direction. So what happens is, based on the moment in x, y and z direction, the x, y, z values that are output are going to change. Now if we see here, by default when the board is lying flat on the table, right, it is flat on the table, okay, you can see the accelerometer on the z axis is 1g. Okay, so that means by default you have acceleration in z axis, and then the other two are almost zero. That means there is no acceleration there. Now if we move this board horizontally, completely horizontally, we should expect that this is in the x direction, right? We should expect that the z should go 0, and as x has increased in the opposite direction to the ground, we should expect -1 on the x side. So you can see there is -0.98 which is printed here, which is almost equivalent to -g, and the y is still 0, and the z has become 0 as well. Now let us put this in a direction, okay, where you get a acceleration of 1 on the x. Now as we have reversed the direction, the acceleration is expected to go to 1, and you can see exactly 1 on the x side, okay. And if we see, if we move this particular sensor in this direction, okay, whatever you do, the board is horizontal, and you always see that the z always becomes 1. Now let us assume we have mounted the board like this. You must expect the y-axis to become 1g here, okay, and you can see it has become -1 in between, and both x and z has become 0. Now in the same case, when you move this board this way, you should expect the acceleration to become 1, and it has become 1 here. So what we are trying to explain here is the acceleration in different directions can be measured by using the accelerometer IC that is present on this particular Arduino Nano 33 BLE board. And we have a small code written here, okay, where we are trying to print the accelerometer, okay, on the X, Y and Z directions. We are right now also printing the gyroscope and the magnetometer value as well. So in this video we will restrict our discussion to accelerometer. So this particular accelerometer, right, BMI270 that is there, can have acceleration up to plus or minus g, plus or minus 2g, 4g, 8g and 16g. So it can have higher acceleration as well. So how do you measure that acceleration? Okay, now let us assume you have a board like this and you are moving at a very faster speed. Okay, you can actually see that the acceleration changes beyond g, okay, and it goes to a higher value. Again, how much you are able to read depends on the sensitivity of the sensor here. Okay, so how fast you are able to read, like for example, if we are moving it slowly, okay, you can see that the sensor value changes. So the sensitivity, the acceleration that we read and all are part of the design, the requirement that you have as a part of the application that you decide. So this is a basic thing about the accelerometer that is present, and this particular accelerometer code, note that if you are using the BMI270 along with Arduino Nano, there are several libraries available. Okay, if you search for BMI270, you can see there are several libraries available. Ensure that you only install Arduino underscore BMI 270 underscore BMM 150. This is the library that is supported by the Arduino Nano board. Any of these libraries, BMI 270 underscore sensor or the SparkFun, is having some trouble, and this particular library has worked really well for us, and you ensure that this is the library which is used by your code. You call that particular header file and use the specific methods inside that file. Okay, and the coding is straightforward. We are just trying to read and then print the values. Okay, so as we are using the library, we actually call the function read acceleration of ax, ay, az, which actually gives us all the three values, acceleration on all the three directions. Okay, so a code which is very simple, you can actually generate it using the ChatGPT as well, and then experiment on different XYZ directions. So in this particular code, what we did is we are actually collecting the DHT11 as well as the sensor code as well, and then we are trying to print that and then send the data over BLE as well.